Hello everybody. So today we are going to solve house number 3 problem. So what's the problem statement is, and the thief has found himself a new place for thievery again, and there is a one interest to this area that is called root. Okay, so we can rob money from each house given a root node, and we can entry from this node. Okay, and we have to rob one house, then we cannot rob house adjacent to that. That means we have to rob either this one. If I rob this house, then I cannot rob 2 and 3. And similarly, if suppose I not rob this house number 3, which is having money 3, then I can rob this and rob this also. Okay, so out of all these possible cases, we have to return the maximum amount of money that can rob without alerting the police. If two directly connected or linked house is broken, then on the same night it will be alerted to the police. So we have to find the maximum amount. What are the possible cases? Like suppose at a particular I am this house, so I can rob this house or I may not be robbed at this house. Out of two possible cases, I have to return the maximum one. So let us solve this. So let's make a function which is taking the root node or the tree node root. Okay, and I will check that if there is exists root, means it is a value, it is actually having null value. Okay, so if it is null, then I have to return the 0, like I cannot rob any more money from the house. So if it is not null, then I can go to the left house as well as right house as well. So if the money in this house is equal to a, will be root dot val, like I am getting root of value money from this house. Okay, and I have to check like if from this I can go to the left side as well as right side. So I will check that if root of left is present or not. Okay, and I will also check if root of right is present or not. If root of left is present, then I will simply add the values of that two, like calling the function plus calling the function again. I will call the left of left subtree. Okay, like suppose at this place, if root of left is present, then I cannot rob this house, so I will rob this and this. So out of I am adding this value. So at this index I will call root of left the many from the root left of left. Okay, and also the many that can be get from root of left of right. I can rob this one, so I can add the values of this one. Also I will add the values of a plus equal to the money that can be get from right of that subchild. So function by calling root of right of left and plus function by calling root of right of right. Okay, I am getting that much money. So if I rob this current house, then I will get a amount of money, and if I not rob this house, then I can rob what the money from left and right. So I can simply call root of left and root of right. Okay, so I am getting money A by robbing current house, and I am getting money B by not robbing the current house. So out of those two cases, I have to return the maximum of A comma B. That will be our final answer. So let us call this function, return this function. Function will be taking the root value. So let us try to check the whether it is correct or not. Yeah, so it is correct. And if I submit this, then it is taking too much time. Also it's got time limit exceeded because lots of similar function callings are there, which is a recursion. So I have to just optimize that by restoring the calculated value, that is so that repetitive function will not called. So I have to make some map. So unordered map of tree node star and int value. Let's suppose dp. Okay, and I will pass this dp vector here, and also unordered map of, like this only, unordered map of tree node and root and the int value. So by reference only, and before calling that I will check if I have calculated the root value or not. If it is I have already calculated, then return this value. Okay, and if I haven't calculated, so I will first calculate it and then store that value in the root. Okay, and that should be maximum. And I have to pass all these in functions like root and this function also in this function and this function as the dp vector. And let us run this. And yeah, so if I submit this, let us try to check what happened. Yeah, 99.926%. so finally successfully submitted this mail. So thank you for all for today.